Hi, today we're going to create a random coin spawning system in Roblox, and we'll look at two different ways to achieve it, with each one giving you a different amount of control or effort needed to implement it. Then you can decide which one's best for you. Once we've done this, we'll convert the code into a class so you can package it up and reuse it across multiple projects. Let's get started. Option 1 gives you maximum control. For our first step, we need to start by defining the number of spawn points. These points are where the coins will appear. The downside of doing this is it's not completely random, but if you add enough spawn points, no one will notice. The upside is you have complete control of where the coins will appear. Now let's move them all into a folder and create the script that will spawn our coins. Then we need a reference to all the coin spawn locations that we've made. We're going to use the collection service for this. I'll walk you through it here, but once you've completed this tutorial, if you want to get more detail on how to get the full potential of the collection service, I recommend you check out my video. The links are on the screen now and in the description below. So we need to open the tag editor, and to do this, we select the View tab, Tag Editor, and it will open on the side here. We create a new tag called Coin Spawn Location and highlight all our coin spawn location parts, and then we select the tag. We go back to our script and reference the collection service. This script is going to need to do two things for us to spawn our coins. Find all the spawn locations and continuously run to spawn the coins. So let's reference the coin from server storage. Now we need to create a method to set our pickup locations. We're going to add our locations to the table, which we're going to call pickup spawn locations. And in our set pickup locations, we call the collection service getTagged function. This will return us an array of parts that's been tagged with the pickup spawn location tag. So we can now loop over these parts and add them to the table. Let's check that this has worked by getting a count of how many items are being added to the pickup spawn locations table. And you see the number of parts that's been added is 24. That looks about right. So let's delete this print statement. And now we need to create our loop to spawn our parts. The first thing I do is add task.spawn so we don't block any additional code from executing. I then force the code to pause for a random amount of time, between half a second and 2 seconds. I use math.random again to generate a random index between 1 and the number of parts that's been added to the spawn location. I've named it random index because I'm going to use this to select a part from the array that we've created. I now clone the coin, set its position to the position of our spawn point and parent it to the workspace. Finally, I call the method, and before I run the game, I need to wrap all that code in an infinite loop so we can continue to spawn coins. We're getting our coins, but they're spawning in the ground and we really don't want that. The only reason this happens is because the coin spawns at the halfway point of the spawn part. And I didn't anchor them, so they fall to the ground, which means our coins are spawning halfway in the ground. So I go to all the parts, anchor them, and that'll fix that problem. Option 2 is minimum control. Let's create a new script, disable the old one, and this one's going to give us a much more random way of generating coins. The downside of doing it this way could be that coins spawn in unwanted locations, sometimes almost on top of each other. The upside is that it's a lot less effort to maintain and it's genuinely random. We start by creating a spawn area. You could use the base plate, but for this example it seems to make sense to have a small spawn area. First we need to reference our coin from server storage. This script is going to need 3 things for us to spawn our coins. It'll need to work out what the boundaries are for spawning, in this case our spawn part, randomly calculate the spawn position within those boundaries, and continuously run to spawn the coins. We start by working out the area in which we can spawn the coins. So we need to reference the create spawn part, and reference that here so we have a way of storing the coordinates boundaries. We'll start by working out the area in which we can spawn a coin, and we need to reference that here. And we also need to have a way of storing coordinates for the boundaries. So I'll add a spawn bounds variable. Next we create the set spawn bounds function. We first get the spawn area's size and position. We're going to use these to effectively draw the boundaries. To work out the boundaries, we're going to use the X and the Z axis. The X-axis will calculate the edge of the front of the boundary, while the Z-axis will calculate the left edge of the boundary. And having these values will give us an area where coins can be spawned. To get the minimum X coordinates, we take the x position and minus it by the x size divided by 2. To get the maximum x coordinates, we take the x position and add the x size divided by 2. This works because the x position is the centre of the part's axis. So getting the size of the axis, dividing it by 2, gives us half of the part's full size, then minus that from the value of the centre gives us the position of one corner. If you add it from the part centre, then it'll give you the position of the other corner. We then do the exact same for the z-axis. Now we have our boundaries, we need a way to calculate the position randomly within there. So we create a getRandomPosition function. In here we create a new instance of a random number generator, then passing the min and the max x values to the next number function. This then generates a random number between the two values which we've passed. We do the same for the z-axis and hardcode our y-axis because we always want them at the same height. Then it's all returned in a vector free because we're going to use this as a position property for our coin. Finally, we create our spawn function. This will be very similar to this previous spawn, so we go there and copy it in. We get rid of the random index and the random spawn location variables, change the new coin position to getRandomPosition, let it run and see what we get. It failed because I was referencing the wrong name for the spawn area. We called it spawn part. Now I've fixed that, we can see that the coin spawning is working as we expected. If you want to learn how to create the next step and give a cool currency giver, so you would collect coins and that coin collection system would cause a screen animation, then there's a link at the top of this video and there's also one in the description below. So let's look at the two options which we've done and consider which one's best. Well, option 1's good for you if you have a lot going on in your map like this. But option 2 may be more suited if you have a more open space map like this one. But ultimately it depends on what your scenario is. But now you have both options and you can decide which is best for you. But before we go, let's convert our code into a class so we can use this across different projects. Now if you don't know how to implement OOP in Lua, this video will give you the basics of what you need to know to implement this random coin spawner. But if you want to know more, I've got a video about OOP, which I've got a link on the screen now, or you can check it out in the description below. First we assign the index property for the object, then we create a function that will create a new instance of the class and we pass in 3 parameters. The locations, which is where we want the coins to spawn, the spawn rate range, which is how often we want the coins to spawn, with a min and a maximum time value, and the item which we want to spawn. We don't want to lock this down to just coins, so we can just pass in an item and have something different every time we call this class. Because this class won't do anything if it doesn't have a list of spawn locations, we want to make sure we have them. If not, we're going to throw an error. Next we add the location, spawn rate range and item properties and assign them to the class. This class is going to be able to implement both options that we've created. And we've already started this process by passing in a table of locations to our new function. You'll see how that helps later. Let's grab the code that we created earlier and update it. Here I've got the code from our implementation that gets all the spawn pickup locations. Let's remove the hard-coded wait times and pass in the spawn rate range lower and the spawn rate range upper. Next we need to change the pickup spawn locations to reference the new locations property. And instead of directly referencing our coin, we can reference the self.item and clone that. The script still needs a bit of work doing it, and if we call it, we'll see the problem. So let's do that now. To call our class, we need to create a new script, require our pickup spawner, and get a reference to the coin. Next we need to create a new instance of the pickup spawner and pass our spawn part in. We pass our spawn location in as array because the locations property assumes that the past value is an array. Then we pass in the spawn rate range and finally the coin. All that's left to do is call the function spawn pickup at random. And it appears that only one coin has spawned, but the reality is that multiple coins are spawning. If we were to use this with the option where we had multiple spawn points, then it would do the job. Let's take a look at that. To do it, we first need to reference the collection service, define our tag and call getTagged. We then pass in the result, which is an array of parts. So now we run it. and we can see it works as expected. But what we currently have forces us to use multiple spawn points. To rectify this, we need to create a random position which we will use to set our new item. We already have the code to get a random position, so let's copy that over from our previous script. But now we should be referencing class properties, and we want to keep this function private, so we need to pass in self so that has a reference to those properties. This function previously referenced a property called spawn bounds. We use that to calculate the max and min positions at the start of the script. But we're now going to do that each time the coin spawns based on the part which has been provided to us. So we update the spawn bound function so it returns all the values that we need to calculate the spawn position. Now we update the random number position to spawn these values, along with creating a vector free which we return. And finally, we want to get the random position and assign that to our new coin's position. By doing it this way, we're allowing the calling script to pass a collection of spawn points or a single or multiple larger spawn areas or any combination of them. If we now pass spawn points that are really small, then the difference between the random position that's generated in each one won't be noticeable when it's generated. But the opposite is true for larger spawn areas. So having this setup allows you to have multiple spawn locations that you can manage and have complete control of where the spawning happens, while still allowing you to have more true random generation of coins. If you have any questions, drop them in the comments below. I'm Tony from Humpop Gaming. I'll see you in the next one.